Now that we've seen the formal definition, let's make it visual. The epsilon delta definition can look complicated at first, but once you see the picture, it becomes much cleaner. This table breaks the definition into the smaller pieces and translates each part into normal language. For every epsilon greater than 0 means for every positive distance epsilon from L, no matter how small epsilon is, epsilon measures the vertical closeness. There exists a delta greater than 0 means there is a positive distance delta from A. Delta measures horizontal closeness. This statement means if x is closer than delta to A and x is not A, then f of x is closer than epsilon to L. If x stays close enough to A, f of x stays close enough to L. Now, let's look at the picture. This is where everything comes together. These two blue horizontal lines form the epsilon band. This band shows how close we want f of x to be to L. Everything within this band is acceptable. Everything outside is not. Epsilon controls vertical error. These two red vertical lines form the delta strip. This shows how close x must stay to A. Delta controls horizontal restriction. If x stays inside this delta strip, then f of x stays inside the epsilon band. That is the definition in picture form. In the first picture, epsilon is relatively large because the requirement is not very strict. Delta can also be large. In the second picture, epsilon is smaller. Notice that delta also becomes smaller. In the third picture, epsilon is even smaller. Then we must choose even a smaller delta. And epsilon gets smaller, delta must also get smaller. If you demand tighter vertical accuracy, I must restrict the horizontal input more. No matter how small epsilon is, I can always find a delta that makes this work. That's what it means for a limit to exist. Now, let's talk about how to actually prove the limit using epsilon delta. Always start by letting epsilon greater than 0. Then start with the expression absolute value of f of x minus L that represents the vertical distance. Then use algebra to rewrite it in terms of absolute value of x minus A. We're working backward here. Once you find what absolute value of x minus A must be less than, that becomes your delta. Delta usually depends on epsilon. Now assume that x is within delta of A. Use your assumption to show that the vertical distance is less than epsilon. Then conclude the limit. Now that we understand both the picture and the strategy, let's apply this to a specific example.